Today we're going to talk about how to multiply matrices. Multiplication of two matrices is very different from what you're used to. You need to pay extremely close attention. So in multiplication, each row of the first matrix is going to be combined with each column of the second matrix. Let's take a look at how that's done. So I have two matrices here, A and B. I'm going to take the first row of A and combine it with the first column of B. I'm going to take first element and multiply it to first element, 2 times -4. Then I'm going to take second element and multiply it to second element, 5 times 4, and then I'm going to add them together. So I would get -8 plus 20 gives me 12. Because this was first row, first column, it's going to be element 1, 1 in my new matrix. Then I'm going to take that first row again and now combine it with a second column. So first element to first element, 2 times 3, second to second, 5 times 9, gives me 6 plus 45 for a total of 51. Because it was first row, second column, this is going to be element 1, 2 of my new matrix. I'm going to do the same thing with the second row, first column, and the same thing with the second row, second column. So that my new matrix becomes 12, 51, 44, 63. There's a couple of issues that this causes. First of all, the number of columns of the first matrix has to match the number of rows in the second matrix. Otherwise, you won't have an even number of elements to multiply together. If they don't, if the number of columns in the first doesn't match the number of rows in the second, you simply state it's either not possible, or you could say no solution. And third, if you can multiply matrices of different dimensions within these rules, but the resultant matrix may not have the same dimensions as where you started. So for instance, let's just take a look. Can I multiply matrix M times matrix L? Can those be multiplied together? Notice how M is a 2 by 1 matrix. L is a 2 by 2 matrix. The number of columns in the first has to multiply the number of rows in the second. If that's not the case, like with M and L, that's not possible, or I could have written no solution. However, if I go the other direction, L times M, now I'm multiplying a 2 by 2 to a 2 by 1. So the number of number of columns in the second does match the number of rows in the first, and that's okay. So in matrix multiplication, order does matter. It is not commutative. So then I can multiply. I'm going to take 3, 6, -2, and 7 and combine it with the matrix 1, 4. So I'm going to end up with, I'm going to do 3 times 1, first row, first column, 3 times 1 is 3, 6 times 4 for second element times second element gives me 24, 3 plus 24 gives me 27. Down here I'm going to do the second row combined with the first column, -2 times 1 is -2, 7 times 4 is 28, that's going to give me a 26, and I don't have any more columns in the second matrix to combine, so I'm done. Notice how my resultant matrix is a 2 by 1. Can I multiply L times P? Absolutely I can. 2 by 2 can always be multiplied to a 2 by 2. So I'm going to take first row, first column, 3 times 5 gives me 15, and 6 times 9 gives me 54. 16 plus 54 gives me 70. So my element 1, 1 is going to be 70. First row, second column, 3 times negative 2 gives me negative 6. 6 times 1 gives me 6. Negative 6 plus 6 gives me 0. Now I can move to second row, first column. I'm going to get negative 10 plus 63 for a total of 53. And last, second, for element 2, 2, I'm going to get 4 plus 7 is going to give me 11. Can I multiply P times M? You bet we can. Let's take first row, first column. 5 and negative 8 gives me negative 3. Second row, first column is going to give me 9 plus 4 gives me 13. And I don't have any other columns in my second matrix, so I'm done. Let me know if you have any questions. You're going to do the assignment in your workbook, pages 497 to 498. Good luck!